Right, let's have a look at how we identify the limiting and excess reactant in a chemical reaction. And we're going to start off with a pretty classic analogy for doing this. We're going to take a recipe for making a burger. So here's my recipe. I need one bun and one patty to make a pretty boring, pretty dry burger. So now let's imagine we are given a specific amount of ingredients in order to carry out this recipe. You can see I've got 4 buns and I've got 3 burgers. And what we're trying to work out is how many burgers we can make and what's going to be left over. Now you can probably just do this in your own head. You can see that, well, each of those 3 burgers is going to need a bun, which means I'm going to be able to produce 3 burgers and have 1 leftover bun. And because there is a leftover bun, we say that the buns are in excess, meaning that my buns that I started with, we could call the excess ingredient, which simply means there's too much of them. They're not all going to be used. And conversely, if I look at the burgers, which ran out before I could use all of the buns, we're going to call those the limiting ingredient, which simply means that they run out first and effectively stop my process at that point. And in this case, that means I've got 1 bun left over. So you can probably do that example in your head, but what we want to be able to do for chemical reactions is try and explain that process using a bit of maths, and specifically we are going to consider the ratios in both my recipe and then the ingredients I'm given. So we'll lay this out in a little table. The top right or the right hand column, we're going to have the ratio. So first of all, let's have a look at my recipe again. And in my recipe, the ratio of buns to patties was simply 1:1. Now it's going to be helpful for us to express this ratio just as a single number. So in order to do that, I simply take the ingredient on the left, which is a ratio of 1, divide it by the ratio of the other ingredient, which is also 1. If I do 1 divided by 1, that gives me a ratio of 1. So if we now compare that ratio with the ratio of the ingredients we were actually provided with, which was 4 buns and 3 patties, so a ratio of 4:3, we're now going to express that ratio as a single number by doing the same thing again. I'm going to do this time 4 divided by 3, which gives me an answer of 1.33. Now the key point here, because that ratio is larger than the ratio in my recipe, meaning 1.33 is a greater number than 1, it must mean that the top part of my ratio, in yellow, is too big, so there were too many buns, and the bottom part of the denominator, which was my patties, my 3 patties, is too small, and that's why my ratio ended up being larger. So by having a larger ratio than my recipe, it means I've got too many buns, not enough patties. So using that kind of scientific terminology, I would say that my buns are in excess and my patties are the limiting ingredient in this case. So let's now try and apply that to a chemistry-based question. Let's take a balanced equation. In this case, we're going to have a look at the reaction between nitrogen and hydrogen to form ammonia. And you can see that my ratio in this case is, and again we're focusing on the ingredients, or the reactants would be the correct scientific term, we've got a ratio of 1:3 between my 2 reactants. Again, let's now express this as a single number by doing 1 divided by 3, which gives me 0.33. So let's now imagine that the question told me I am using 0.1 moles of nitrogen and 0.4 moles of hydrogen. Now, like with the burger example, you might in your head be able to quite quickly work out the limiting and excess reactant, but with more complicated numbers, it's going to be helpful to follow this process. So again, we want to consider what the ratio is between my 2 reactants. So I'm going to do 0.1 divided by 0.4, and that's going to give me 0.25. So now we're going to compare those ratios again. And with the amount of reactants that I'm given, I've got a ratio of 0.25, which is smaller than the ratio we need in my balanced equation, which is 0.33. So if my second ratio is smaller than the first one, it must mean that the top number, which is the 0.1, is too small, and the bottom number, 0.4, is too big. So I could say that there is not enough hydrogen and there is not enough nitrogen and too much hydrogen, which is the number on the bottom. So applying our specific terminology here, I could say that the nitrogen is the limiting reactant and the H2, or the hydrogen, is the excess reactant. As a quick summary of those steps, let's jot those down. So here's a little summary. First thing we need to do is calculate the mole ratio in my balanced equation. Secondly, we need to calculate the mole ratio of the reactant amounts that are actually given in my question. And then, depending on how those ratios compare, for example, if my reactant mole ratio given in the question is bigger than the mole ratio in my balanced equation, then that must mean that my first reactant is in excess, there's too much of it, and the second reactant is limiting. And the other way round, if my reactant mole ratio given is smaller than the mole ratio in the equation, well, that must mean that the first reactant is limiting, there's not enough of it, so it's going to run out first, and the second reactant must be therefore in excess. And the final step that you can check out in other videos is that once we've identified the limiting reactant, that is going to be the amount we use for further calculations. So that might be calculating the amount of products that are produced in the reaction, and we can actually also use it to work out how much of my excess reactant was used up, and then I can take that one step further and work out how much then is left over or in excess. And that will do it for limiting and excess reactants. Hopefully this video was of some help.